Today's lesson, over section 3.2, we're talking about the product and the quotient rule. So for the product rule, if I use the definition of derivative and kind of manipulate this notation, I can separate f times g of x plus h into two separate functions and do the same thing for fg of x. And if I rewrote that, I want to create something here, so I can actually subtract f of x plus h times g of x plus f of x plus h minus or times g of x. And that allows me to separate two things into two different limits, factor out an f of x plus h and a g of x, and then because of what I have remaining, those are actually representing the derivative of g prime of x and f prime of x. So I'm able to come up with the product rule. Because we have the product rule, now I'm able to find the quotient rule by manipulating that with the following expressions. If I let a capital F of x be equal to f of x divided by g of x. And so really what I'm doing here is I'm kind of notating, because I'm saying f of x is equal to f of x times g of x, I can use the product rule to rewrite that and then move some things around. So it looks like I'm moving capital F of x times g prime of x to the other side. And because I know that capital F of x is f of x divided by g of x, I can insert that in, make some common denominators, and then I'm able to show that capital F prime of x is f prime of x times g of x minus f of x times g prime of x divided by g of x squared. Okay, so this next slide is really just the product rule and the quotient rule just set aside. And this is what we'll use to kind of be able to deal with a multiplication and division when we're given different functions. So let's go ahead and give this a shot. So for example 1 here, I have the multiplication of two kind of functions. And so what I'm going to do is I'm going to take the derivative of the first, which is going to be 2x minus 5 times the second, so x cubed plus 4, plus the derivative of the second, which will be 3x squared, and then times the first. And so that's kind of the notation that I use there. So then from there, now I want to try to simplify, so I'll have to multiply the first two parentheses out and then distribute the 3x squared to the second one, and then look for like terms. So in doing so, I get 5x to the fourth minus 20x cubed plus 8x minus 20. And that would be my answer. For letter B, I'll do the same thing. Remember that the derivative of e to the x is e to the x. So I take the derivative of the first, which is 2x times e to the x, plus e to the x times the second, or the first. And then I can factor out an e to the x. Leaves me with x squared plus 2x. And then from here, I can actually factor out an x. So I can get x times e to the x times x plus 2. And that would be my final answer. Okay? So example C, we want to change the square root of t to 2 to the 1/2, and then take the derivative of the first, which would be 1/2 t to the negative 1/2 power times the second, and then derivative of the second, which will be negative 2t times the first. And then from there we want to kind of distribute and put like terms together. So we get 1/2 t to the negative 1/2 minus 1/2 t to the 3/2 power, and then minus 2t to the 3/2 power as well. So here I have like terms of t to the 3/2. So I'm going to put those together. So 1/2 t to the negative 1/2 minus 5/2 times t to the 3/2 power. Here I'm going to factor out a 1/2 and a t to the negative 1/2 power. That allows me to get 1 for the first term, and then the 1/2 makes it 5, or negative 5. And then taking out a negative 1/2, remember that's division, so it's like 3/2 minus a negative 1/2. So then that allows me to get 4/2, which is 2. Okay, letter D. Now with the quotient rule, I'm going to take the derivative of the top and divide it by, or times it by the bottom. So the derivative of the top would be 3x squared minus 4 times the bottom. Now here, because it's quotient, I subtract, and I take the derivative of the bottom, which will be 10x plus 2, and then times the top. And then because of the notation, the denominator becomes the same thing but squared, so it doubles. Think of like if it's first power, you moved it up, then it becomes negative, like -2, and then you move it back down, so it's actually squared or moves up 1. So that's kind of what's happening there. So here, I'm going to multiply all my terms out. I'll distribute that negative through to the first pair, or the first binomial, so it becomes negative 10x minus 2. And then I'll do the same thing, so multiply the negative 10x by everything and the negative 2 by everything. And then from there, I want to look for like terms, so 15x to the fourth and negative 10x to the fourth are like terms. 6x cubed and negative 2x cubed are like terms as well. Negative 20x squared and 40x squared are like terms. Negative 8x and positive 8x cancel each other out, leaving you with negative 30x and then a minus 6. So after all the like terms are put together, I'm able to get 5x to the fourth plus 4x cubed plus 20x squared minus 30x minus 6, all divided by 5x squared plus 2x to the second power. Okay, thanks for watching.